Land-based nutrients effect on duration and intensity of red tide events. This is going to be provided by Dr. Miles Medina from the University of Florida Center for Coastal Solutions. Next slide. Purpose of this is to provide findings from a recent study to identify systemic cause and effect relationships between red tide and anthropogenic drivers. The relation to our CCMP is that this relates to water quality improvement action 5 to reduce harmful algal blooms, specifically 5.1, supportive HAB research and monitoring and measures to reduce their environmental, social, and economic impacts through the ID and reduction of anthropogenic influences. I'll now turn this over to Dr. Medina. Thank you for joining us this morning.
All right, thank you. It's a pleasure to be here, and it's a privilege for any scientist to be able to speak to decision makers and policymakers. So thank you for the opportunity. I'll be presenting on some of my recent work linking red tide blooms near Charlotte Harbor to nutrients and discharges from the Caloosahatchee River. Next slide, please. Okay, so we'll start off just by looking at some data and some background information. The video on the left shows the red tide data near Charlotte Harbor from about the last 10 years, and these are the data that we used in our analysis. Each frame shows samples collected in the area during a 2-week period, with each dot representing a red tide sample and the size of the dot corresponding to the amount of red tide in the sample. So blooms show up as clusters of red dots. And as we let this video play, I'll just give some background information on red tide. Dr. Hubbard just gave an excellent sort of background already, but I'll just highlight a couple of relevant points here. So, of course, we're concerned about red tide blooms because they're associated with economic costs, particularly to tourism and real estate, and also they're associated with public health problems, ecological damage, and wildlife mortality. The organism itself, Karenia brevis, is a type of phytoplankton, meaning that it does photosynthesis like plants, but it also requires nutrients from the environment. And as Dr. Hubbard indicated, it's not a picky eater. It can use nutrients in a variety of forms, including both organic and inorganic nitrogen. So what causes these blooms? Yes, thank you. We can stay on the last slide, please. Yeah, great. Okay, so what causes these blooms? So it's well known that these blooms occur naturally, but it's also suspected that human or anthropogenic influence can be important. As Dr. Hubbard indicated, blooms start offshore due to natural processes, and then ocean currents and circulation patterns can set up a sort of conveyor belt that moves them to the coast. And once they're on the coast, the blooms can be maintained and intensified by local nutrient sources, which might include nutrients that ultimately come from our cities and farms. And it's this last part that my research focuses on. Okay, next slide, please. All right, so the big question is whether we're making these blooms worse. And I think it's an important question because on the one hand, we can't do much about the natural causes of blooms. For instance, we're not going to change ocean currents in the Gulf, but we can perhaps do something about our own influence on these blooms if it turns out that we're having a substantial impact on how intense these blooms become and how long they last. So let's dig into this question a little bit deeper. First of all, we know that it's possible that humans are causing these blooms to become more intense. For instance, we know that the Karenia brevis organism can use the forms of nutrients that we put out onto the coast, nitrogen, phosphorus, and so on. We also know that the amount of nutrients we're putting out has increased over the past couple of centuries as our population has grown and land use has become more intense. Finally, we know that the amount of nutrients that we're putting out can meet a substantial portion of the bloom's nutrient requirements. So on its own, our nutrient output isn't typically enough to sustain a bloom, but it's substantial enough to be concerned about. So it is certainly plausible that we could be making blooms worse. Now, researchers have also looked at the data to see if there is a link between human activity and blooms, and here the results have been mixed. So on the one hand, there's often a correlation between blooms and river discharge, that is the amount of water coming out of rivers along the Gulf. But there hasn't been much evidence of a correlation between blooms and nutrients coming out of those rivers. So is that the end of the story? That is, if we don't see a correlation, does it mean that our impact must be too small to really worry about? And I would argue that the answer is no, not necessarily. So it reminds me of the story you may have heard about a guy looking around for his wallet under a lamppost, and someone comes along and asks if this is where he lost his wallet. And he says, no, but this is where there's light. So this problem is common to all of science. We're always limited by the information and data we have available and by our ability to ask and answer the right questions. So what I would say about this correlation issue is that the real question we're concerned with, whether humans are making these blooms worse, is fundamentally a question about causality. And it's worth remembering that correlation doesn't necessarily imply causality. Of course, two things can be correlated, but completely coincidental and not actually related. On the other hand, it's just as important to understand that there can be a causal relationship without correlation. So in other words, correlation can only tell us about simple, straightforward relationships. But of course, we know that algae blooms and the processes that influence them are complex. So one interpretation, one possibility from these earlier studies that found no correlation between blooms and nutrients, it could be that these studies are really just pointing to a more complex relationship. For instance, whether and how nutrients affect blooms might depend on other factors and other conditions being met. And the same input of nutrients might have different effects on blooms at different times, depending on what else is going on in the system. So to tie it back to the lamppost story, maybe we have just been asking the wrong question or looking under the wrong lamppost by focusing on simple correlations. Okay, next slide, please. All right, so to investigate this question, we formulated two hypotheses. First, we want to know whether the water and nutrients coming out of the Caloosahatchee River are intensifying blooms. That is, are these things making them worse? And we look at the relationship between blooms near Charlotte Harbor and conditions in the Caloosahatchee River at station S79. So S79 is where water from the river discharges out into the estuary and ultimately into Charlotte Harbor and the Gulf. Next, if the answer to this first question is yes, then we want to know how much of the watershed is involved in contributing to these blooms. That is, can we trace the influence further upstream? So we investigate the second hypothesis by walking upstream from the Caloosahatchee River station, S79, to the Lake Okeechobee station, S77. This is where lake water is discharged into the Caloosahatchee. And then we can walk further upstream to the Kissimmee River station, S65E, and look for causal relationships between each pair of stations. We focused on the Caloosahatchee River, Lake Okeechobee, and Kissimmee River Basin, since this is the major flow path in the watershed, and because these are the areas with enough data to support this type of causal analysis. So it's worth mentioning that the Myakka River, the Peace River, and other basins, particularly coastal basins, are also important parts of the watershed. And I'll also point out the land uses on the map on the right. The map shows the various basins within the Charlotte Harbor watershed. And you can see that urban areas in gray and agricultural areas in yellow really dominate. Next slide, please. Okay, so now I'll get into the results. So first, we found that red tide blooms and Caloosahatchee River nutrients and discharge showed strong signals, which represent a systematic pattern of behavior in each of these variables. The time plots on the right show the data for each variable in black and the signals in red. These signals are predominantly seasonal, as you might expect. And the presence of these signals or systematic patterns of behavior implies the possibility that there are systematic cause and effect relationships at work. And ultimately, we're interested in whether land-based nutrients like nitrogen and phosphorus systematically fuel red tide blooms. Next slide. So moving on to the causal results, when we look at data from 2012 to 2021, we find that blooms near Charlotte Harbor were systematically influenced by nitrogen and by discharge from the Caloosahatchee River. And there were some interesting time delays detected in these relationships that I won't have time to get into. In contrast, we did not see evidence that other water quality parameters like phosphorus concentrations or specific conductance systematically affected the behavior of these blooms. It's not to say that they don't have an effect, but they're not really determining the behavior of the blooms in a detectable way. And finally, it's worth pointing out that this analysis includes tests to ensure that we're not just mistaking coincidence for causality. That is, it's possible that Any relationships are just coincidental, since nitrogen and bloom cycles are both seasonal. But the results for nitrogen and discharge both passed these tests, so we can conclude that there is a real causal relationship to blooms here. Okay, next slide, please. Okay, now going a bit deeper into this relationship, the next thing we want to know is about the nature of the relationship between blooms on the one hand and Caloosahatchee River nitrogen and discharge on the other. It's one thing to say that there's an influence, but what we really want to know is whether these inputs are making blooms more intense or making them last longer. So the analysis, indicates that discharge and nitrogen both systematically intensify coastal red tide blooms. As shown in panel A, where both curves are strictly positive. The blue curve represents the influence of discharge on blooms over time, and the black curve represents the influence of nitrogen on blooms. Further, we found that while discharge and nitrogen both consistently act to intensify blooms over time, when these effects are the strongest depends on what stage the bloom is in. So the effect of discharge was typically strongest in the early part of the bloom cycle at the beginning of a bloom. And the effect of nitrogen was typically strongest later once blooms were already established. So this implies that the water flowing out of the river may affect blooms both as a carrier of nitrogen, but also through perhaps a separate mechanism. For instance, it's possible that large discharges from the river change circulation patterns in Charlotte Harbor and might actually draw red tide water in from the Gulf through the various inlets. This is just a hypothesis at this point, but it's a possibility that's currently being explored by researchers at the UF Center for Coastal Solutions and elsewhere. On the other hand, nitrogen seems to play its most important role in maintaining, intensifying, and therefore prolonging blooms. Next slide. Okay, so investigating our first hypothesis showed us that nitrogen inputs from the Caloosahatchee River intensify blooms. And moving on to the second hypothesis, we want to know whether this influence can be traced upstream to Lake Okeechobee and to the Kissimmee Basin. And indeed, the causal test did indicate relationships upstream. The behavior of nitrogen at the Caloosahatchee, that's station S79, is influenced by nitrogen at Lake Okeechobee, that's station S77. And the nitrogen conditions at that station are influenced by nitrogen further upstream coming out of the Kissimmee River, station S65E. Next slide. So to summarize the results, here's a causal diagram showing the influence of nitrogen from the Kissimmee Basin to the lake, to the Caloosahatchee River, where nitrogen inputs and discharges to the coast ultimately intensify red tide blooms. In this figure, the TN and NOx stand for different forms of nitrogen, that's total nitrogen, and nitrate, inorganic nitrogen. And the Q in the Caloosahatchee River row stands for discharge. KB at the bottom is Karenia brevis, or red tide. Next slide, please. So to summarize, here are a few takeaways. First of all, red tide blooms occur naturally, but the evidence indicates that we can make them worse. How much matters, but so does when in terms of nutrient inputs. So it's not just about the quantity of nutrients we're putting out to the coast, but it's also when, particularly relative to the stage of the Karenia bloom cycle. We also saw how correlations don't tell the whole story of human influence. The second takeaway is that nitrogen-enriched discharges from inland areas in the lake consistently intensify coastal red tide blooms. It wasn't the focus of the study, but of course, coastal urban areas also contribute nutrients, obviously, to Charlotte Harbor, and presumably also can help sustain blooms. So these nutrient sources are, septic systems, fertilizers, stormwater, and so on. And previously, as an environmental consultant, a very common piece of advice, a recommendation I had for coastal municipalities as clients was to consider partnerships with upstream cities and counties, state and federal agencies, and state legislators. I'm originally from South Florida, from Miami, and living on the coast is great. You've got the water, beaches, sunrise or sunset, depending on which side you're on. But unfortunately, that living on the coast also means you're kind of the last stop for nutrients and other things that originate outside of the boundaries of your city or county. So these partnerships can really help develop projects and kind of share costs to mitigate these problems on the coast. And then finally, just to talk about some of the work we're currently doing or looking forward to at the Center for Coastal Solutions at UF. This year, we're going to be identifying areas and land uses that contribute most strongly to coastal red tide blooms, so from throughout the watershed. We also have researchers working on simulating Charlotte Harbor hydrodynamics to understand how Caloosahatchee River discharges affect circulation patterns and water quality. And also in collaboration with the Army Corps, we're modeling flows and water quality between the lake, the Caloosahatchee River, and Charlotte Harbor to develop alternative lake discharge operations and schedules that reduce negative impacts on coastal water quality. And fortunately, that's something that the Army Corps is concerned with. Okay, so next slide. That pretty much concludes my talk. Here's some contact info. The work I just presented is a manuscript that's currently in review. We also have a prior study from 2020 that's already published, so I'd be happy to share any of that if you just want to reach out to me through email. And our website, UF Center for Coastal Solutions, is right there. So thank you for your attention, and I'd be glad to take a couple of questions.
Dr. Medina, thank you for that presentation. And it definitely seems like you're talking to the right group with that recommendation that you highlighted of, coastal areas working with upstream inland partners. That's exactly what this Coastal and Heartland National Estuary Partnership was formed to do. And we expanded in recent years for just that purpose, for the recognition of the benefit that we can have in collaboration. So with that, Alice, I see you've come on. Do you have a question?
I didn't have a question, but I just want to say I appreciate you bringing up the term a causal relationship. I think that's the first time I've heard that used, and I appreciate that, because the pushback that I get from people, because here in Northport we are starting on a septic to sewer conversion plan and getting a lot of pushback from people that are claiming it's not me, it's somebody else. I'm not, and then they're thinking about a direct cause, but sometimes, as you said, it's a series of steps, as you pointed out, with the Kissimmee going to the Lake O to the river and then to the Gulf. So all those things along the way have to be considered. So it may not be you're the only one, but you're contributing to it, and that's a causal relationship. I was trying to think of an analogy, like when they determine smoking may be hazardous to your health. It's not like, okay, if you smoke, you're going to get diabetes, but they have figured out that there is a causal relationship that is more likely to happen. So I'm always trying to think of ways to think of other analogies to help people understand what we're talking about as far as the influence of excess nutrients and how that contributes to the red tide blooms. So thank you for bringing that up.
Yeah, thanks for the comment. And that's super important with any environmental system or environmental challenges. I mean, these are very complex systems, and we want to make sure when we're analyzing data that we're using the right tools that kind of respect that complexity.
I had a few questions if you've got a minute.
Sure. Could
you go back to slide, I think, was it number 58? It's number 58, I guess, the chart. Yeah, right there. Explain to me a little bit, like I see that 65E is where the Kissimmee River inputs into Lake Okeechobee. Is that correct?
Correct.
And those symbols there, NOx and TN, that's nitrogen?
Yeah, so NOx is nitrate plus nitrate, so that's inorganic nitrogen, and that's one component of TN, or total nitrogen.
Okay. And then is Lake Okeechobee coming out of Lake Okeechobee 77. Then of course coming across the Caloosahatchee is where the addition of those nutrients are coming in that are listed there, the phosphorus and what have you. They're they're not present coming out of 77, but they're showing up coming down the Caloosahatchee. Is that what that means?
Not quite. That's a good point, and maybe this isn't clear enough here. So this the presence of these different things in the Caloosahatchee row just indicate that we looked at those, tested for causality. So for example, we tested for causality between PO4 or phosphate, TP, total phosphorus, as drivers of Karenia brevis on the bottom. The reason that they don't appear up on the top two rows is that because there was no causal connection between the Caloosahatchee phosphorus, for example, and the Karenia on the coast, we didn't go further upstream and look for drivers of that driver, right? So basically we looked at, we found nitrogen as a driver, and we were interested in kind of pursuing that further and seeing if that's a driver, if that's originating sort of upstream, but we didn't do that for the ones that we didn't find a causal connection.
But Miles, the constituents would have been present in the lake,
yes,
and the Kissimmee as well.
Yes,
so
absolutely. Yeah.
Constituents. And I just so wanted to recognize that we have partnered with University of Florida, this Coastal Institute. The CHNP has entered a formal partnership with them to do water quality analysis. So we are, I just thought that was one thing I would add that Miles didn't mention, is that we are now engaging with them to continue this work.
Okay, last question. Are we measuring nutrient inputs in the Kissimmee River Basin or at the headwaters, I believe, if I'm correct, is the headwaters of the Kissimmee River, the Shingle Creek area? Are we measuring inputs to on the north end of the Kissimmee River? And if we are we detecting inputs coming from the headwaters of the Kissimmee River?
So there are stations throughout the basin. Off the top of my head, I can't speak to their exact locations or the availability of data in terms of like when and how often these samples are collected. We, for this study, just looked at sort of the bottom of each basin, the bottom of the Kissimmee, the discharge point of the lake, because that sort of integrates everything that's going on in the basin to some extent. For the next study, I'm actually going to be looking, a little more detailed into each basin and using the data that are available, and perhaps some remote sensing data as well, to try to increase that spatial resolution. But so to answer the question, yes, there is monitoring throughout these basins. We didn't use all of that for this particular study.
Okay, thank you.
Yep.
Mr. Chairman,
thank you again, Doctor, for your presentation and discussion. Again, if there's any other questions that folks want to put in the chat, there's also an opportunity for direct follow-up with Dr. Medina. His information is shared in this.
I believe we have one more question here in the room.
Oh, okay, please go ahead.
Mr. Chairman, Ken Doherty, a great presentation, Dr. Medina. Just to find it curious that the high flows out of the Caloosahatchee are transporting nitrogen to the north up to Charlotte Harbor. And it's related, but it's interesting that maybe we can extrapolate if, like you say, the red tide's not picky as to its food. It's not a picky eater, but, we got other algae. We have this other species that are creating problems with our seagrasses along the east wall, especially. So I really appreciate your study, because it may be connected to what we're seeing relative to the seagrass dying along Charlotte Harbor. So I really appreciate your work, and as it relates to red tide, but I think we can extrapolate it to these other things too, probably. Thank you very much.
Sure. Yeah. Thanks for the comment. I want to be clear that when I say Charlotte Harbor, perhaps I'm being a little loose. I'm kind of referring to the whole area, so including Pine Island Sound and Matlacha and so on. We are doing work though on looking at those circulation patterns. And of course, this area is all very interconnected with flows and circulation and so on. So that's an important point and an issue and subject of a lot of ongoing research. Yeah.
Thank you.
All right. Again, thank you, Dr. Medina. It was a wonderful presentation.
Thanks. It's a pleasure.